Structural and Mechanical Design at Anechoic Chamber. He recently graduated with a Master of Science degree in Aerospace Engineering from the Tohoku University. Please give a warm round of applause to Engineer Ariston and Gonzales.
Good afternoon and thank you for the introduction. So today I'm going to just go on and put more emphasis on the work that we're doing with the academe and as a research institution. So today my slide will be about the role of research institutions and opportunities for the industry. So hopefully at the end of this presentation, we can find some ways where we can collaborate and continue this endeavor in space. So let me start off my presentation by showing a very iconic photo taken at the moon. So it's by Neil Armstrong on his first footsteps on the moon. So it's very popular that the message that he said when it's one step for man and a giant leap for mankind. And it is a very giant leap indeed, because just a few decades later, it's not only encapsulated in the form of space agencies, the kind of endeavors that they had on space. So in 2007, the X Prize Foundation, sponsored by Google, placed a contest for privately funded organizations, where they said that the first team to send a rover on the moon and travel just 500 meters and send high-definition photos of the moon will be awarded $30 million. So this sparked a kind of new space race for a lot of groups all over the world. But actually, just recently, a few weeks ago, the first one to do that on the moon is not the private companies yet, but another space agency, but this one from China. So they actually landed their rover on the far side of the moon, Chang'e 3. I don't know if I pronounced it correctly, but it's a name. And they have a very, interesting mission going into the far side of the moon. So one of the missions that they're trying to, or experiments that they're trying to conduct, is to grow this cotton sprout on enclosed container. So it actually survived for a few hours, but during the eclipse phase, where the temperature reached around -120 degrees, so it's still there. But I think it's a good progress coming from the Chinese Space Agency. But of course, hindi pa rin nagpapatalo called the private sector. So a very popular company called SpaceX, headed by CEO Elon Musk, is still dreaming of going far beyond our own Earth. And in fact, he already has a roadmap for going to the moon themselves by sending non-professional astronauts, so just tourists or those with deep pockets, to go and travel around the moon. And in fact, he already has a name for his rocket or spaceship. He called it very vaguely the Starship, that will go across the space. And a few months ago, a billionaire, Mr. Japanese Yusaku, is already on a contract to go on that first journey to the moon with SpaceX. So with all of these kind of institutional and private endeavors, so the space race is always about something. But for us, the Philippines, as a nation, I think that's one of the questions we want to answer. What kind of mission or philosophy do we want to go on as we embark on a journey, like a journey to space? So hopefully we can find some answers with the presentations we have for today. So let's go back contemporarily to what kind of endeavors in space are really generating some money nowadays. So as already mentioned by Dr. Marciano, it's the computers that we send into near-Earth orbit that are generating more impact in terms of economy and society for Philippines, for the Earth. So a lot of satellites are being sent yearly, and it's about to increase even further in the next few years because of the new low-cost launchers and the developments in the form factor and the technology of satellites. Now, and as mentioned, it's not about just sending these computers into space, it's about generating data. And it's the data that provides a lot of call this impact to us here on Earth. And in fact, already mentioned earlier also by Dr. Dennis, is that data is being monitored as the new oil or the new gold. So I like this image because it shows that the companies right now that are generating a lot of profit and impact to the society are not necessarily companies that provide a hardware or a product that you can just touch, but it's mainly about data and how it provides impact to us in our daily lives. So just an example again, just to elaborate further on the companies that were represented, is that they're being more creative in the way they engage with data. So instead of just waiting for the financial results of, let's say, Walmart, they indirectly use these satellite images and assess how much profit they're going to generate at the end of a quarter and provide this to Wall Street and other investment companies. So, and also in terms of management of resources, so for a resource like oil, which is important everywhere in the world, knowing the price ahead of time of this commodity is of value to a lot of people and nations and companies. So this company just takes a collection of all the storage facilities for oil and try to assess the level of the amount of oil that we already have in these facilities and generate an information or sort of predicting how the price will be in the next few weeks or months. So it's a very interesting way to approach data. But again, going back to the Philippines, the kind of data that we are also motivated by are those that provide more informational and actionable information. So it's not alien to us that we are considered a very disaster-prone country. And we experience this every year ourselves in the urban area or in the rural area. A lot of damages and challenges are being presented by these calamities. So for us, as simple as this, perspective from space of calamity zone provides so much information and actionable data that it's enough of a motivation for, at least for our organization and the institution, to send our own computers to generate the data similar to this. So this photo is actually from Yolanda in 2013. So I don't know if the projector is doing it justice, but the simple qualitative information that you can see from the damages and where building or infrastructure used to be is already actionable on its own on the ground people that we have and the limited resources that we have on the ground. So for us at the PHN Microsat program, it's already part of the big motivation to provide this kind of end product to the stakeholders. So, and in 2016, we launched the DIWATA-1 microsatellite into space with the Earth observation mission. This program was actually started around 2014, and we formulated a team that will go and embark on this journey, and we were thankfully funded by DOST-PCIEERD to go on and proceed with the project. So let me just take some time to acknowledge some of the people we have on our team here on the audience. So we have Engineer Guba, Dr. Retamar, Dr. J. Perez, so people who have worked all these years to send these computers into space and provide actionable data to our stakeholders. So DIWATA-1 is a 50 kilogram Earth observation microsatellite. So when we were building this is just like a CPU, computer CPU that you're working on, putting a video card, removing a RAM. So it's this form factor is very similar to that. But the impact that it can provide is way beyond, of course, the standard CPU. And just last year, we also launched its successor, the DIWATA-2, with the same mission of Earth observation and for a lot of disaster response and communications during emergency. But this one was launched at a much higher altitude, at 600 kilometers. Because DIWATA-1 was launched at 400, and at 400 kilometers, the lifespan is around just 3 years. In fact, when we started with our first projection, it was only around a year or 18 months at the worst case. But thankfully, the conditions are much better for the orbit, and we still have DIWATA-1 in space. But of course, if we want to provide longer value, we wanted the next one at a higher orbit. So DIWATA-2 has that kind of orbit at 600 kilometers. So we're hoping for it to have at least a minimum of 5 years of operation and lifetime. So the mission, as mentioned, is still going to be Earth observation with focus on post-disaster assessment and environmental monitoring, our assets on the ground. And the latest one that we have with DIWATA-2 is for communications during emergencies. And as we know, during a strong typhoon, the traditional cell sites of communications providers tends to get affected easily by strong typhoons. And during calamities, we need this kind of fast response on the ground. And the way of communicating wirelessly is a very important tool. So we have an onboard module on DIWATA-2 called the Amateur Radio Unit that will help us use the satellite as a sort of relay during this calamity. Now, my emphasis for this presentation on the technical side is more on the things that we have developed locally here in the Philippines and tapping local industry to help us deliver the experimental modules. So, namely, they're a solar position measurement, or it's a measurement of the sun's position relative to the satellite. And then we also have an attitude control determination unit, an experimental one. So attitude in this scenario just means orientation. So the satellite's orientation control unit. And then, of course, as mentioned earlier, we have an amateur radio-based module that we developed. Broadcasting system. So whenever it's over a certain calamity zone, we can transmit some messages that amateur radio users can receive on the ground for, let's say, a disaster response scenario. So the way we go about it is, earlier, we have a very manual way of tracking the satellite with amateur radio. So literally, I mean, these are not the guys that we have, these are foreigners. But very similarly, we have a Yagi antenna that we point into the sky, roughly. But nowadays, we also try to automate the process by doing systems locally and fabricating them ourselves. So we try to 3D print the rotating system and then just using the low-cost Raspberry Pi computers to do the process. So this kind of system are being done. And then the orientation control unit is something that we are working on with the, more rigor, because we believe that this kind of system will help us in our future heritage of satellites that we're going to develop. And later I'll show you some other applications where it can be used aside from satellites. But this module, as a close-up look, we try to do it in an economic way. So minimize the custom parts and try to maximize the off-the-shelf commercially available parts that we can procure easily online. So as you can see, there's some popular semiconductor part in there. And then, but the important thing here is the custom design that we implement to integrate all of them into one single unit and perform this orientation control. And it gives us a sense of pride that even from the simple PCB, you can stamp that it's made in the Philippines. And you can put the Philippine flag right there and say that it's made in the country. And more importantly, once it's launched into space, you can say that, the country's flag is orbiting there, sort of, in this small PCB. So, but of course, this is not possible without the help of professional fabricators from the industry. So, with this endeavor, we're trying to source out a lot of these, development parts of the cycle that we can tap our local industry So in this case, we tried PCB fabrication and some of the enclosure, mechanical enclosure fabrication, and of course the layout, the assembly of the small parts locally. So we're still in the process of qualifying them, or at least getting the feedback from space, from these modules, but we're very positive that they're functional and that they're providing the intent that we had from the start. So another thing that we implemented with DIWATA-2 is deployable solar array panels. So the mechanical system to do this is, if you think about it, it's simple, but it's very critical and very important to be qualified and to be tested thoroughly. And one of the things that we want to do also in the future is to maximize the capability that we have in terms of producing the solar panels themselves locally. So we're still in the process of finding a partner. But I think all through this development, the important thing whenever we embark on these complex systems is the way we test and qualify them. So for DIWATA-1, DIWATA-2, on the module level up to the whole system level, we have to undergo several environmental tests. So let me name some of them. For example, we have a radio pattern test, antenna pattern test that we conduct on an anechoic chamber. So the anechoic chamber is just simply like a facility that blocks out the other electromagnetic waves from real-life sources like cell phones and other devices. So in here, it's important that we ensure that the antennas or communications module that we have on the satellite is going to work. Because the thing about sending things into space is that it's almost always a one-way trip. There's no way of repairing them whenever you need to. So you have to qualify them on this chamber to ensure that they're working seamlessly. And then another important test is what we call the vibration test. So it's not the vibration that it experiences in orbit, but more of the transit going to space. So the rocket launches that we have introduces a lot of vibration into the system. And then another one is the thermal vacuum test to ensure that it's performing in the vacuums and constantly changing thermal conditions in space. And of course, we have to test it for some radiation tolerance because the radiation outside our atmosphere is worse than it is on the ground. So in satellite DIWATA-1, there are 423 volts externally. So just to demonstrate how the satellite experiences the vibration, let me show you this video from the live testing of the engineering model of DIWATA-2. So I showed the number of volts because it's quite a lot for 100, but just one that fails from that volt on this test, the whole mission would already fail on the ground. So for example, the vibration test facility, we utilize several in Japan, one in near Tohoku in Miyagi, and then the chamber and facilities we have in Kyushu Institute, or that they have in Kyushu Institute of Technology. So we have to go to Japan just in order to qualify these parts. And as part of the initiative that we have in the academic institution is, as mentioned earlier by Dr. Marciano, is to establish facilities that we can capitalize on as a research institute, and that also that the industry can use in their own purposes. So we already have the full anechoic chamber in Tripoli, and we also procure just a small one, vacuum chamber that we can use for qualifying the small units. So that was DIWATA-1, and let me just go through some of the other products that we have, because aside from just the computer itself, of course, again, the important part is the kind of data that we can provide to the stakeholders. So over the lifespan of DIWATA-1, we've taken more than 10,000 images of the Philippines and some parts of the Earth. And qualitatively, you can see a lot of things. For example, like the edge of the Earth, you can already prove that it's not flat Earth or something. And then this one is the first image by DIWATA-2, pointing directly toward the Philippines. Unfortunately, there was some cloud formation, so we're just seeing a lot of clouds and some typhoon brewing in the Pacific. So of course, we also take a lot of photos of the agricultural areas and the coastal areas that we have. So visually, you can see all the features of the Philippines. But importantly for us, the research that we want to embark on is one that delves in remote sensing. So as simple as, for example, the extent of flood after a typhoon, and using a more, what you call this, understandable data. So for example, this one, blue means flooded area, and then the green is still the plains. So if you have a before photo of that one, you can already compare and then use that visual guide for your assets on the ground. And for example, this island, Shangri-la Island, we can show how the development of the island is ongoing, or how much extent of the build-up is already being established on that island. And with that simple color-coded remote sensing data, we can already tell the story in a more instant manner. So what are the other activities that we are embarking on in Tripoli? So later, my colleague will talk about the cube satellites that we are developing and launching to space, and the program that we have in the institution. And another thing that I want to mention is that we tried contacting to the astronauts on board the International Space Station using the amateur band. And here's a snippet of that moment when the students ask their questions to the astronauts. So there's no audio, but it's on our Facebook page, so you can check it out. But I think the important takeaway here is that we were hoping that it helps inspire the students and the future engineers and scientists that we have into embarking into this kind of endeavors. And hopefully now they're talking to the astronaut in space, but maybe in the future they're the ones talking down to us in the Philippines. But the way I imagine it, maybe our astronaut will have all these kind of sponsorships, possibly funded by the commercial fee. So yes, maybe that's Manny Pacquiao right there in space. But I mean, but the important thing is that we have our own Filipino engineers or scientists up there doing important mission for, not only for the Philippines, but for here. So, just to summarize it, sorry for the time, but we have a lot of plans to develop all the necessary modules in order for us to take this development to the next level. So we're planning to build test systems, computers on board that can help us build this heritage towards the future of development in space. So again, as being mentioned earlier, we're really hoping to have our own space agency here in the Philippines, because the important thing for us is it will help us embark on more, projects that will provide hopefully more impact to the society and to the economy. And this slide, I guess one of the takeaways from this presentation is that this will not be possible without the help of all these stakeholders doing all the development and other things to make it successful. So we at the university and in the academy are doing our part in terms of research and providing the kind of technology to make the mission successful. But of course, without the local industry to help us and the policy-making agency to provide that roadmap, it will not be as easy. So just a few more slides, just to show some of the examples of the products that has been done or has been created by simple products coming out from mid-space missions of NASA. So for example, the camera phones that we have, actually GPL started these small sensors for their scientific mission in space. And then of course, the air thermometers that we now use frequently is used for infrared measurement of space back then, but now it's being used in a more commercial manner. But of course, as we look forward, we're looking at systems that will take advantage of, for example, the orientation control units that we develop, like UAVs for blood delivery or even remote sensing itself. And then of course, another way of interacting with the spaces that we have in virtual reality. And maybe the way we traverse the ground itself will be affected by the developments that we do in space. And maybe not only on the ground, but the way we travel. So maybe that's one of the things that can be helpful. But of course, in the Philippines, we hope, we can build satellites that can provide more value like DIWATA-1 and other satellites like Landsat-8, and a way of sending the satellites into space. So as mentioned earlier, a private company, SpaceX, is doing their own rocket launches into orbit. But maybe in the Philippines, we'll have something like that. Pero, again, maybe funded by a lot of industry partners in that sense. And of course, we can go into some more sci-fi kind of mission, like going to Mars, like Elon Musk wants to build the city. But again, in the Philippines, maybe more realistically, it's more about, again, sending these computers into space, providing data to the Philippines. And it's not always going bigger is better, but for us, the perspective is also doing it in smaller form factors, but in tandem with other smaller computers. So maybe in the future, other academic institutions or private companies will have their own microsatellites and will have their own consortium providing data in a real-time fashion. So let me end my slide with this one. So this is my favorite photo of all the development initiative we had. So it's like an arts and craft project. So this is what we call a mock-up. So in building your system, before you even go to your computer-aided design work or simulation, you have to plan it out in a more traditional fashion, like an architectural building, right? And I love this photo so much because who would have known that in 2014 it's just cardboard, and a year and a half later it will be in space. So let's all reach for the stars and work together. So thank you very much.